video, I will teach you not only how to implement the portal physics but as well as the portal gun mechanics for your 2D game. It took me 3 whole days to get to this point, and no combination of Claude, Gemini or ChatGPT were of any help along this journey. So you might want to stick around till the end of the video, because God forbid this was tough. And truthfully, this video has been only possible because of Mario, a mashup between Super Mario Bros. And Portal created by Stab Yourself, from which my code has taken heavy inspiration from. Okay, so as always, let us first jump into the logic and then the code, because trust me, you will want to hear the logic for this first. The logic on paper at least is actually pretty simple. First, let us talk about the portals. Let us say you have 2 portals and you enter from the blue one and exit out of the orange one. Now what should happen to you in this scenario? Well, first and foremost, your position should change. I mean, obviously that is the point of this whole portal. Secondly, your velocity with which you enter the portal should change as well. I mean, that is how you get the clips you saw in the beginning of the video. And in my opinion, that is the whole fun factor of the portal mechanic. Now, let us take a deeper look of what exactly changes between the initial velocity and the position. Firstly, the position is pretty simple. We just change it to our exit portals, that is the orange one. However, we also add in some buffer amount to this position. Why? Because so that we don't accidentally hit the colliding box of this orange portal and warp back to our original position. Basically a slight hack so that we don't teleport automatically back to our original position immediately. Okay, moving on to the velocity. The first thing we want to do is to actually preserve our initial speed. By saying speed here, I mean speed in terms of physics. That is the magnitude of our initial velocity. Secondly, we apply a force onto the player in the direction perpendicular to our portal's exit, or in another word, the forward vector of our portal's mouth. Let us call this direction D. Thus, our new velocity becomes a vector having its direction as d and magnitude as our initial speed. Now that is it for the logic behind our portal. Now let us see the logic behind our portal gun. From our gun, we will be continuously shooting a ray pointing towards the position of our mouse. Whenever we click our button to create a portal and our ray is intersecting or rather colliding with the wall, then we will instantiate our portal at that intersection with its mouth facing towards the normal of the wall. Or in another word, we will instantiate our portal with its back against the wall so that we can actually enter through its mouth. And once our portal gun creates the 2 portals, we will just link both of them together so that we can actually enter and exit out of them. Pretty simple so far, right? Now here is a curveball that took me 3 days to solve. For our player, or rather any character body 2D node, we do not use the built-in move and slide function. I again repeat, we do not use the built-in move and slide function. That function hates portals. So what do? We create our own custom move and slide function. Inside that function, if we are colliding with a portal, we do not slide our velocity on that particular frame, because if we do, we literally destroy all of the momentum and we have to build up our velocity back again starting from 0. You know what, let me show you what happens if I use the standard movement slide. As you can see, that was not fun at all. So anyway, that was it for the logic part. Now let us code it all out. Firstly, let us go over our initial setup. We just have a basic level made up of tile map containing our player, which is a character body 2D node. The player has a sprite and a collision box as well as a node 2D containing the portal gun under it. The player has the typical movement script, apply gravity, move left and right and jump, etc, etc. And lastly, our portal gun, which continuously aims at our mouse and also emits a ray in the direction of length 1000 pixels. As for project settings, this is our input map, a typical WASD based movement and input keys for shooting our blue and orange portal, which we will use later on. And finally, here are the collision layers that we will be using. Okay, now let us start with building our portal. Okay, our portal will be an area 2D containing its sprite and its collision box. You can also give it a aesthetic glowing effect like I've done here using Polygon 2D. However, that is not the main point of the tutorial today, so I will skip over that. But that is something you can do as well. Before moving on with the code, I want you guys to make sure that your portal is by default facing in the right direction. That is, its mouth is by default pointing towards right. Why? Because in my code, I will be making the assumption that the default forward facing vector of the portal is the right. Although I will point my assumption when we get there in the code, so it should not be too difficult for you guys to make adjustment accordingly for your game. Okay, enough yapping, on towards the code part. We will create references to two variables. One is our linked portal, that is the portal this is linked with. In other words, our exit portal, and the other is our exit buffer, which I mentioned in the logic part. Our main driving function will be the teleport object function, which will teleport any portal entity that comes across it. This portal entity is the one with the custom move and slide, which we will define later on. First and foremost, if there is no portal for us to teleport out of, we will not begin the teleportation in the first place. I mean, obviously. Anyway, our new position will be this exit portal's global position. Next, we write the variable to preserve our current speed, which I have clamped till 20,000 in order to prevent us from clipping out of the world. And for those curious about that 1.1 multiplier, that is just for pure fun. Next, we define the direction in which we exit out of the portal, or in another word, the forward-facing vector of our exit portal. So how it works is that, as I said before, we assume that the vector to the right is the default forward-facing vector for any portal. We then rotate this vector along the angle rotated by our exit portal. For example, our exit portal is on the floor and is facing the up direction. By default, it should have been facing to the right. However, by facing up, it has actually moved 90 degrees anti-clockwise from its initial assumed rotation. So we have to rotate our assumption by that angle in order to get the new actual forward facing vector for that portal. Hopefully you guys understood that. Moving on, we then just define our body's new velocity along this new forward direction and give it back its original speed. And lastly, we just change this position with some buffer along this direction as well. Hopefully you guys understood the portal's physics logic, and to actually initiate this logic, we just run this function for any body that overlaps with our colliding box, every single frame. And as a side note, our portal will have its collision mask set to collision layer 1 to actually scan for the portal entities. Speaking of portal entities, now let us code that out. First and foremost, our portal entity will be of type character body 2D. Since we will be defining our own move and slide function, we now actually have to define our own logic for detecting whether we are on the ground or not. So create a variable for it. Okay, to write our own move and slide function, we need to firstly understand what move and slide actually does. So what your move and slide function does is that it detects whether your player is colliding with any other object or not, using the built-in move and collide function. And if you're colliding with what it deems to be a floor or a slope, then it makes you slide along that particular floor or slope, essentially making move and slide just a built-in response to the collision detected by the move and collide function. This is fine and all. However, we do not want our player to slide if we are colliding with a portal. And essentially, this is what we will be doing in the code. That is, we will only slide our player if we are colliding with a floor or a slope and not the portal. Why this is necessary is because our portal lies on top of these floor or slopes, and this built-in move and slide function has no way to differentiate between this portal and the slope. So this is what we will be doing here. Oh, and to detect whether we are on the ground or not, we just check whether the slope of our supposed ground is less than or equal to 45 degrees. If true, then we are on the ground, and if false, then we are not. Now for the portal detection logic, we create a new function called findPortal@collision, pass along our result of move and collide onto this function. If this function returns us any portal that we have collided with, then we just return out and don't slide our velocity. and only slide it if this function returns false. Now let us write the logic behind the find portal at collision function. We firstly get the reference of our 2D space, initiate a new point query. What this query does is that it creates a point at our desired position along this 2D space. We then ask this point to tell us which all objects that it is colliding or intersecting with. We then loop across the results of this query, and if any one of those items is a portal, we just return that, or in other case we just return null or false. So to summarize, our portal entity has a custom move and slide function where we only slide our velocity if and only if the objects we are colliding with is not a portal but a float or a slope, which is different from the pre-built move and slide function in which we slide our velocity irrespective of whether we are colliding with a portal or not. Now the steps to make our player a portal entity is actually very simple. First, change the type of character body 2D to portal entity. Second, change the isOnFloat function to isGrounded variable. And thirdly, change the move and slide function to custom move and slide function. Now lastly, let us look at our portal gun. We firstly make references to both our portals. These two scenes are nothing, they are just a copy paste of that same portal scene I showed you guys earlier. They just have different sprites and nothing else. Could I have changed the code to make use of the single portal scene? Yes. Was I too lazy to do so? Also yes. Anyway, the above two were just packed scenes. These two variables are meant to refer to the actual instantiation of those packed scenes above in our actual game. We then write the function to spawn our corresponding portal. Inside that function, similar to our portal collision function, we will create a new physics query, but this time it will be a ray instead of a point. This ray will travel along the direction pointed towards by our gun and will return back the first wall it is colliding with. If it is colliding, we then instantiate our portals based on our mouse click and rotate them accordingly such that their back will face against the wall. And if both type of portals are in the game, then we will link both of them together. And yeah, this is it. The code is complete. Now we can demo out our game. As you can see, everything is working just as expected. The Goomba is also a portal entity. I think you can write the code for the Goomba by yourself by now. And yeah, anyway, this is it for today. Hope you guys liked today's video. Don't forget to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time. Okay, bye.